we have physics, resultant and equilibriant forces. Now, let me use this. This is called force God to explain resultant and equilibriant forces. Here, if we have three forces, these three forces are in equilibrium. That is force P, force Q, and this force here, E. Let me call here E. That is equilibrium force. 1, 2, 3. They are in what? Equilibrium. Then, if they are in equilibrium, then it implies that the resultant of these two forces is R. And we can obtain this resultant using what we call parallelogram law of vector or triangle law of vector. Then this one pointing downward is called equilibrium force. So resultant point upward, the equilibrium force point downward. So this one is equilibrium of these two forces. Why this is the resultant of these two forces? Then what is the resultant force? Resultant force is that single force which would have the same effect in magnitude and direction as the original forces acting together. That is what we call, this is the resultant. Is the single force that will have the same effect in both in magnitude and direction as these two forces acting together. Equilibrium force of two or more forces is the single force which will balance. This one will balance. This equilibrium balances, which will balance the what? All the other forces taken together. So equilibrium force is the one that, in WAEC, when you ask students, the key word here for equilibrium force is balance. While the key word for resultant is both magnitude and what? Direction. So now, note that equilibrium force is equals to resultant force. E is equals to I, but both of them are acting in opposite direction. Therefore, if the resultant is 10 Newton, then it implies that the equilibrium force will be minus 10 Newton. That is to say that they are equal but opposite. Given that the forces below are in equilibrium, calculate the resultant and the equilibrium force F. The resultant of these two forces and the equilibrium force F. The three forces are in equilibrium. So now to do this, we will apply what we call parallelogram law of vector. Or you can use triangular law, but let's use parallelogram law to calculate. So what do you need to do? You have to reproduce this. You say so. That is parallelogram law. Parallelogram law, the two adjacent sides. So if here will be what? 10 Newton. Then produce this line now. This angle will be equals to 60. So here now will be 180 minus 60. Here will be what? 120 degrees. Then we use what we call cosine rule. Cosine rule states that here now we are looking for R. R is the resultant. We now have R square equals to 10 square plus 5 square minus 2 times 10 times 5 times cos 180 minus theta is 60. 180 minus it will give you 120. R square equals to 100 plus 25 minus 2 times this is 20. 20 times 5 is 100. Cos 120 should be minus. Here is minus 0.5. Then we now have R square equals to 125 minus, this times this you have minus 50. Then minus times minus will give you plus. We will now have 125 plus 50 to give you 175. Then R is equals to square root of 175. 10 points, approximately to 13.2 Newton. This is the resultant. Then you know that when we when we define resultant, we say it will have the same effect in magnitude and direction. So this is the magnitude. We need to find direction. Now using alpha equals to tan inverse of p sine theta all over q plus p cos theta. You make use of this formula, or you can use sine rule. You can use sine rule, or you can use this formula. So using this formula, we have alpha, which is the direction. Alpha stands as our direction. Tan inverse of p is 10 times sine 60 all over 5 plus 10 cos 60. So tan inverse sine 60 is 0.866 all over 5 plus 10 times 0.5, which is cos 60, equals to tan inverse of 8.66 divided by 10. Alpha equals to tan inverse of 0.866. Then alpha equals to 40.892. Alpha approximately to 41 degrees. Therefore, our resultant force is 13.2 Newton. Alpha equals to 41 degrees. Then the equilibriant force. Second one is to find the equilibriant force. Equilibriant force will now be equals to minus 13.2 Newton. Remember, I told you that equilibriant force is equal to resultant force but acting in opposite direction. So if resultant force is 13.2 Newton, then equilibriant force will be minus 13.2.